Here's integrated 3. It's problem 7-36. It says when Loretta was 18 years old, she deposited $100 into a 20-year certificate of deposit account that earns interest at a better rate than her standard savings account. She must leave the money in the account for 20 years without making any withdrawals or deposits. 6 years later, she had $132 in the account. Write an equation that will represent this situation and use the equation to determine how much money Loretta will have in her CD after 20 years. So this one, we need to set up an equation, and hopefully it would make sense to you that we're going to use an exponential equation. We've been doing this well, you weren't here in class. We've been doing this. So I'm going to just get out my exponential equation model, y equals a times b to the x, and then I'm going to write down the information I know. So I know that when she was 18, she started out with $100, so I can make an ordered pair 0, 100. And then it said in the problem that 6 years later she had $132. So A is always the starting point. So we know that A is 100, so I'm going to go ahead and just plug that into my model. So this is just the model y equals a times b to the x, but I've plugged in 100 for A because that's my starting amount. And you might remember that B is our multiplier, so B is going to be like the rate that her account is growing. And then we're going to use x for the amount of time. So we need to use our ordered pair that we have to plug in and find B. So we'll plug in for y, we'll plug in 132, and for x we'll plug in the 6, and then we just use our algebra. So you would want to divide this on both sides. And then you'd have b to the 6th, 132 divided by 100 would just be 1.32. And then so b to the 6th is to the 6th power equals that. So to get the b by itself, you can undo the exponent by taking the 6th root. The 6th root of both sides. And if you can't find any buttons on your calculator that'll help you take the 6th root, like mine, see how mine you can just punch it in. You could also just raise both sides to the 1/6 power. That would also work. So you calculate that. I calculated b was equal to 1.047-ish. Okay, so now we have b. So we had a was 100, we have b, and remember it's y equals a times b to the x. So we'll just say y equals 100 times b, which was 1.047 to the x. And then the rest of the problem is just asking us, well, to write an equation. So there's our equation, and then determine how much money she'll have after 20 years. So all I have to do is just plug the 20 in right here for the x. So equals 100, 20. So we've got to use the order of operations when we do this. I already have the number in my calculator, so I'm just going to raise the unrounded number to the 20th. And then, so that gave me this number you see on the calculator, and then I multiply it by 100. And I got that really there's only going to be $252, and we would round that to 30 cents and 30 cents in the account. And I'm going to check that and make sure that's right.